Welcome back to AIMS tutorial. In today's session we are going to discuss about complex number, specifically about iota, what are the properties of iota and problems came in 2021-20 related to iota. What is iota? Iota means I, that is under root minus 1 is called iota. So before discussing properties of iota and problems related to iota, so first let us learn few things about complex number. So what is complex number? So any number of the form a plus ib, any number of the form a plus ib is called a complex number where a comma b are real. Any number of the form a plus ib is called complex number. For example, complex numbers are generally denoted by z. So 3 plus 4i is a complex number. Z equals to 3 is a complex number. Z equals to 4i, also complex number. This 3 we can write 3 plus 0i, therefore it is a complex number. 4i we can write 0 plus 4i, therefore 4i also complex number. So any number that is in the form of a plus ib is called complex number, where a is called a real part and b is called imaginary part of the complex number. What about a? A is here a real part of the complex number and b is the imaginary part of the complex number. Now here few terms which are very important in complex number. So let us discuss about conjugate of a complex number. So what is conjugate? Two complex numbers are said to be conjugate if their sum and product both real. Two complex number are said to be conjugate if their sum as well as product are both real. They are of the form a plus ib comma a minus ib. For example, z is a complex number. What about z? Z is any complex number that is in the form of 3 plus 4i, then its conjugate is denoted by z bar, that is 3 minus 4i. Vice versa, if z equals to 2 minus 3i, then its z bar is 2 plus 3i. Just we have to change the sign before I. If a plus ib is there, its conjugate is a minus ib. And what about conjugate of a minus ib? That is a plus ib. Now next topic is modulus of a complex number. Modulus of a complex number. If z equals to a plus ib, what about z? If z is any complex number that is in the form of a plus ib, then root over a square plus b square is called the modulus of z and it is denoted by mod z. If z equals to a plus ib, then root over a square plus b square called modulus of z. For example, z equals to 3 plus 4i, then modulus of z, mod z equals to root over 3 square plus 4 square, that is 3 3s are 9, 4 4s are 16, root 25 is 5. So mod z equals to 5. So root over a square plus b square is called modulus of complex number. Next, polar form of a complex number. If r is the modulus and theta is the argument of a complex number z, then z equals to r into cos theta plus I sin theta, which is polar form or mod amplitude form of z. Okay, if z equals to a plus ib, then z equals to r times of cos theta plus I sin theta is called polar form or mod amplitude form, where r equals to root over a square plus b square and theta equals to tan inverse of b by a is called mod amplitude form. For all values we can write z equals to r times of cos 2k pi plus theta plus I times of sine 2k pi plus theta, where k belongs to z. We will discuss about this one in de Moivre's theorem. Okay, so if z is a plus ib, then its polar form is z equals to r times of cos theta plus I sin theta. Now a few basic properties of complex numbers. If z1 equals to a1 plus I b1, if z1 equals to a1 plus I b1, z2 equals to a2 plus I b2. First condition or first property, if z1 equals to z2, if two complex numbers are equal, means their real parts are equal, that is a1 equals to a2, or imaginary parts are equal. And also Okay, so if z1 equals to z2 means both having same real part as well as same imaginary part. So a1 equals to a2 and b1 equals to b2. Second property, z1 plus z2, addition of two complex number. When adding two complex number, just we have to add a real part with real part plus imaginary part with imaginary part. Okay, similarly, difference of two complex number, that is z1 minus z2, here also a real part subtract from real part plus I times of imaginary subtract from imaginary, that is b1 minus b2, a1 minus a2 plus I times of b1 minus b2. Now division of two complex number, that is z1 by z2, actually just we have to rationalize the denominator. After rationalizing, you will get a1 a2 plus b1 b2 by a2 square plus b2 square plus I times of a2 b1 minus a2 b1 by a2 square plus b2 square. So here, for getting this result, we need to rationalize z2. Rationalize means multiply and divide with z2. Now fifth property is z1 into z2. Like natural multiplication, here also we have to expand z1 and z2. If you expand z1 z2, a1 a2 minus b1 b2 plus I times of a1 b2 plus a2 b1. After multiplication, we have to convert in a complex number, that is a plus ib form. Always we have to write either z1 by z2 or z1 into z2. Z1 plus z2 or z1 minus z2. Always a plus ib form. Okay, complex number form we have to write. Yes. Second formula, power of iota. What about iota? Iota means I, that is under root minus 1. So under root minus 1 is denoted by I. Okay, I equals to or I power 5 equals to or I power 9 equals to. In general, we can write I power 4n plus 1, that equals to I only. If you multiply with one I, okay, so this I into I become I square, then I power 6 equals to I power 10 equals to so on. This will become I to the power of 4n plus 2. So any number that is in the form of I to the power of 4n plus 2 is I into I square. Value of I square is minus 1. Now if you multiply with one more I, so it will become I cube equals to I power 7 equals to I power 11, so on. In general, I to the power of 4n plus 3. So I cube value is minus I. Next, I to the power of 4. So if you multiply with one more I cube into I power 4 or I power 8 or I power 12, so on. In general, 4n plus 4, or simply we can write 4n again. So I to the power of 4n equals to 1. Okay, so just summarize, I equals to I only if power 1, I square, I into I square, that is minus 1, I cube is minus I, and I power 4 equals to 1. Now do some examples. What about I power 32, 332? See, 332 come in 4 table. So if you are able to write 4 into something, so 4, if you take 4 common, so 4 8s are 32, 12 remains, 4 3s are. So we can write 4 times of 83. So this is I to the power of 4n times. So value of I to the power of 4n is 1. Now what about 1932? So I to the power of, we cannot take 4 common here. So if you take 4 common, 4 4s are 16, 3 remains 33, 4 8s are 32, 1 remains. Okay, so 12, 4 3s are, again this one also we can write 4 times of 483, means this one also I. Now what about 421? So if you take 4 common, 4 1s are, 4 5s are, plus 1 remain. So 420 means we can write 105 4s are, so also 1 remain. So this is in the form of 4 times of n plus 1, that is nothing but our I. So this is 1 only, sorry. Anyway, 4 to the power of n plus 1 is I to the power of 4n plus 1, I to the power of 4n plus 1 is I to the power of 4n plus 2 is minus 1, I to the power of 4n plus 3 is minus I to the power of 4n is 1. I to the power of multiple of 4, I to the power of multiple of 4 becomes 1. So this is very important, we have to remember this one. I to the power of multiples of 4, so I power 8, I power 12, I power 32, I power 4 factorial, okay, I power 5 factorial, 6 power factorial, 7 factorial, I power 100 factorial, all are equals to 1. Okay, some important note. First one, what about 1 by I? 1 by I, if you multiply, divide with I, 1 into I is I into I is I square. But value of I square is minus 1. So I by minus 1 is minus I. Therefore, 1 by I is minus I. Okay. From next onwards, if 1 by I will come, we consider as minus I. Next, sum of 4 consecutive powers of iota is 0. Sum of 4 consecutive powers of iota is 0. For example, I. So we can write I only. I square means minus 1. I cube means minus I. I power 4 is 1. So plus 1 plus I minus I get cancelled. Therefore, sum of 4 consecutive powers of iota is 0. This one also 55. I power 55. I power 56. I power 57. I power 58. Here also I power sum of 4 consecutive powers of iota is there. Therefore, summation is 0. In general, I power n plus I power n plus 1 plus I power n plus 2 plus I power n plus 3 becomes 0. Now, third property is I to the power of 4n. Okay, I to the power of multiple of 4 is 1. I to the power of multiples of 4 is 1. I to the power of 16 is 1. I to the power of 100 is 1. Okay, so I to the power of 4 into anything is there, then it is a 1 only. Now do few problems which came in previous year exams. Okay, the value of summation n equals to 0 to 100, I to the power of n factorial, where I equals to under root minus 1. So summation n equals to 0 to 100, I power n factorial. N start from 0 to 100. So I power 0 factorial plus I power 1 factorial plus I power 2 factorial, so on up to I power 100 factorial. What about 0 factorial? 0 factorial is 1. 1 factorial also 1. 2 factorial means 2 into 1, 2. 3 factorial means 3 into 2 into 1, 6. 4 factorial means 4 into 3 into 2 into 1, 24. 5 factorial means 5 into 4 factorial, that is 5 into 24 is 120. 6 factorial means 6 into 5 into 4 factorial, that is 720. Okay, so what about I power 0 factorial, that is 1. I power 1 factorial also 1 plus I power 2 factorial. What about 2 factorial? Is 2 only. So plus I power 3 factorial is 6 plus I power 4 factorial. 4 factorial plus I power 5 means 5 into 4 factorial, so on. Okay, so I plus I is 2I. What about I square minus 1? I power 6. 6 we can write 4 plus 2. So I power 4 plus 2 again minus 1. So 1, 1, 1 total how many? I power 4 factorial, 5 into 4 factorial. These are multiples of 4. So I to the power of 4n, multiples of 4 is 1. So how many ones are there? So total from 0 to 100, 101 terms are there. 1, 2, 3, 4. So 101 minus 4 is 97. So 1 plus 1 plus 1, total how many ones are there? 97. Okay, so 97 minus 2, this is 2i. I plus I, 2i. So 95 plus 2i. Therefore, summation n equals to 0 to n, I power n factorial is 95 plus 2i. The second problem is summation n equals to 1 to 13, I power n plus 1 by I whole power n, where I equals to under root minus 1. So, if you write this summation, n start from 1 to 13. If you take n equals to 1, I plus 1 by I. If you take n equals to 2, I square plus 1 by I square. N equals to 3, I cube plus 1 by I whole cube plus so on. Up to how many terms? 13 terms. I 13 plus 1 by I power 13. So this one I am writing I plus first terms I square, I cube, I square plus I cube up to I power 13 together, and remaining 1 by I plus 1 by I square plus 1 by I cube up to 1 by I power 13. Okay, so 1 plus 2 plus 3. So this from I to I power 13, we are using the property sum of 4 consecutive powers of iota is 0. So first 4 term 0, next 4 term 0, next 4 term 0. So what remains? I power 13 remains. Here also 1 by I square. So using the property, same property, sum of consecutive powers of iota power 4 is also 0. So here also you will get just 1 by I to the power of 13. So I to the power of 13, 12 plus 1. So that is I only. And I to the power of 1 by 13 becomes 1 by I. Since 13 we can write I to the power of 4 times of 3 plus 1. So 4n multiples of 4 is 1, so just only I power 1, that is 1 remain. So I only. And what about 1 by I? 1 by I is minus I, therefore I minus I is 0. Therefore summation n equals to 1 to 13 I n plus 1 by I whole power n equals to 0. Our answer is 0. So next question is I power 592 plus I power 590 plus I power 588 plus I power 586 so on divided by 582, 80, 78, 76 so on. Okay, up to 74. So many methods are there. Now if you observe, the difference between highest power of I in numerator denominator is 10. So I am taking I power 10 common from the numerator. After taking I power 10, so I power 592 becomes I power 582 plus I power 590 becomes I power 580 plus I power 588 becomes I power 578, and this one is I power 576 plus I power 574 whole divided by, I am writing denominator as it is, that is I power 582 plus I power 580 plus I power 578 plus I power 576, and last one I power 574. Now if you observe, the numerator and denominator both are same, get cancelled, just I power 10 remains. So I power 10, 10 means we can write 4 into 2, 4 8s are 4 2s are 8 plus 2, that is I square. And what about I square is minus 1. Therefore the value of given expression is minus 1. Value of given expression is minus 1. This question is very important. The smallest positive integer n for 1 plus I, 1 minus I whole power n equals to 1. Options are 2, 4, 1 and none. So here we know that, note, write down 1 plus I by 1 minus I, if you rationalize it will becomes I only. Multiply and divide with 1 minus I, so expand using a minus b whole square, a plus b whole square, okay, a plus b into a minus b, whatever may be. So you will get 1 plus I by 1 minus I is I only. Similarly 1 minus I by 1 plus I, if you rationalize you will get minus I. So in the place of 1 plus I by 1 minus I, if you write I whole power n equals to 1, we know that, so I square equals to minus 1, I power 4 equals to plus 1, and I power 8 equals to plus 1. Therefore the least smallest positive integer for n is 4, second option. Okay, so n equals to 4. Next question is related to same previous question. This came in 2020 Eamcet. 1 plus I by 1 minus I whole power m equals to 1, then m cannot be 1934, 2020, 2024, 2028. We all know that 1 plus I divided by 1 minus I equals to I only. If you apply power on both sides m, so it will become I power m, that equals to given 1. We know that I power n equals to 1 means n is a multiple of 4, so check the options whether they are multiples of 4 or not. So first option 1934, if you divide by 4, 4 4s are 16, 3 remains, 4 8s are 32, 1 remains, 14 will remain. Okay, 14. So in 4 table 14 will not come. Therefore 1934 is not a multiple of 4. Okay, 2020, 4 5 0, 4 5 is a multiple of 4. 4 5 4 6 it is also multiple of 4. 4 5 4 7 this one also multiple of 4. So option 2 3 4 are all possible values of m, but first option 1934 is the not possible value of m. So first option. Now next question, 2021. For how many natural numbers n such that n lies between 1 to 2021 is 1 plus I by 1 minus I whole power n equals to 1. We all know that 1 plus I divided by 1 minus I equals to I. If you apply power n, this is 1. For where n is a multiples of 4. Multiples of 4. So the given question, how many multiples are there in between 1 to 2021? So from numbers between 1 to 2021, the last number which is divisible by 4 is 2020. Now divide 2020 by 4. So if you divide 2020 by 4, so 25 are 25 are. So total there are 505 numbers are there. Okay, in between 1 to 2021, for which 1 plus I by 1 minus I whole power n becomes 1. Like for example, if you put n equals to 1, it will become 1. If you put n equals to 4, multiples of 4. So 4 8 12 16 32, like that. From 1 to 2021 there are multiples of 4. Total 505 terms are there. Therefore value of n is 505. Second option is the right option. Now question number 6. Previous year question came 2021 TS. Sorry, AP. So 1 mod 1 by I power 2020 plus 2 by I power 2021 plus 3 by I power 2022 plus 4 by I power 2023. So 2020, if you divide it by 4, 4 5s are 20. Okay, 4 5s are 20. So remainder is 0. Okay, so mod 1 by 1 remains, plus 2 by, if you divide 2021 by 4, 4 1s are, 4 5s are, 4 5s are 20, still 1 remains. So our remainder is 1. Therefore this will become I, plus 3 by, if you divide 2022 by 4, so I square will remain. Like that, this will become I power 3. So 1 by 1 is 1 only. 2 times of, what about 1 by I, that is minus I, plus 3 times of I square is minus 1, plus 4 times of I power 3 is minus I power 3 is minus I. So 1 minus 3 is minus 2I, and what about plus into minus, minus 4 by I, but I value is minus 1, so minus of minus plus 4I. So mod minus 2 plus 2I. Next we have to find modulus of this one, that is root over 2 square plus 2 square is root 8. 4 plus 4 is root 8. We can write 2 root 2. Therefore modulus of 1 by I 2020 plus 1 by 2 by 2021 plus 3 by I power 2022 plus 4 by I power 2023 is 2 root 2. Next question. The value of I power 22 minus 1 by I power 35 whole square. So what about I power 22? I power 22 means we can write 20 plus 2. So 20 is a multiple of 4. So this is I square only, that is minus 1. Like that, what about 1 by I power 35? So 1 by I power 35 means 32 plus 3. So I power 32 is 1, so that is 1 by I cube. So 1 by value of I cube is minus I. So 1 by minus I becomes plus I. So I power 32 means minus 1 minus 1 by I is, that is I whole square. Now we have to expand using a plus b whole square. Since both are minus, a square plus b square minus of minus plus 2ab. So 1 I square value is minus 1 plus 2I. So minus plus 1 get cancelled. Therefore value of the given expression is 2I. Here we are using I power 22 as minus 1 and 1 by I power 35 as I. So minus 1 minus I whole square using a minus b, a plus b whole square. Why we are using a minus b whole square? Both are minus, minus into minus plus. So we have to use the formula of a plus b whole square, that is a square plus b square plus 2ab, not a minus b whole square. Now next question is, if x plus iy 1 plus 7i by 2 minus I whole square, then cosec tan inverse of y by x minus pi by 4. So given is x plus iy equals to 1 plus 7i 2 minus I whole square. If you expand using a minus b whole square, 2 2s are 4 plus I square minus 2ab means 4i. I square is minus 1. So 4 minus 1 is 3. So 1 plus 7i divided by 3 minus 4i. Now rationalizing the denominator. So multiply with 3 plus 4i and divide with 3 plus 4i. Denominator is a minus ib into a plus ib. We know that a minus ib into a plus ib in general, that is a square minus b square, but in complex number it will become a square plus b square. Formula of a minus ib into a plus ib is a square plus b square. So denominator is a square plus b square means 3 3s are 9 plus 4 4s are 16. But numerator 1 3s are 3 minus 7 4s are 28 plus 7 3s are 21i and plus 4i. So minus 25 by 25 plus 25 by 25i. So minus 1 plus I. So if you compare with x plus iy, x value is minus 1, y value is 1. Now we have to find cosec of tan inverse of y by x minus pi by 4. So this will become cosec tan inverse of minus 1 minus pi by 4. Tan inverse of minus 1 is minus pi by 4 minus pi by 4. So 1 minus pi by 4, 1 minus pi by 4 is minus pi by 2. And cosec 90 is 1. Cosec is a odd function, becomes minus cosec pi by 2. And what about cosec pi by 2 is 1. So answer is minus 1. Okay, this one also 2021 previous year question. Now next question is 2021 TS previous year paper. If a plus ib whole power 4 equals to 2 plus 3i, then find the value of 3b minus 2a. Okay, so first write on the given, that is a plus ib whole power 1 by 4 equals to 2 plus 3i. First I am squaring on both sides, so 1 square is get cancelled, still 1 a plus ib whole power 1 by 2 remains, and this will become 2 plus 3i whole square. So that is a square plus b square plus 2 times of ab. So 2 2s are 4, 3 3s are 9, I square is minus 1 minus 9 plus 2 2s are 4, 3s are 12i. So 4 minus 9 is minus 5 plus 12i. Okay, this is the value of a plus ib whole power 1 by 2. Again squaring on both sides. Now a plus ib will remain, minus 5 plus 12i whole square is a square minus 5 whole square plus b square 12i whole square. Actually consider a minus b whole square minus 2 times of 5 times of 12i. So 5 5s are 25 minus, since I square is minus 1, 144 minus 2 5s are 10, 10 12s are 122i. Okay, 12 2s are 24, 5s are or 2 5s are 10, 10 12s are 120. 2 5s are 10, 10 12s are 120i. So what about 25 minus 144? 144 minus 25. Okay, 14 minus 5 is 9. This is the 1 1. So minus 119 minus 120i. If you compare with a plus ib, so value of a equals to minus 119, value of b equals to minus 120. Now we have to calculate 3b minus 2a. 3 times of minus 120 minus 2 times of minus 119. So 3 1 minus 360 minus of minus plus 100 238 238. Okay, so 10 minus 8 is 2, 5 minus 3 is 2, so answer is minus 22. 1 also is there na, so minus 122. Minus 122 means our third option. Okay, we can use binomial expansion also, expansion of a minus b whole power 4. Okay, I am doing just a minus b, a plus b whole square, a plus b whole square twice. Next question is, if z1 equals to 1 minus 2i, z2 equals to 1 plus i, and z3 equals to 3 plus 4i, then find the value of modulus of 1 by z1 plus 2 by z2 into z3 by z2. So first find out 1 by z1. So what about 1 by z1? That is 1 by 1 minus 2i. Multiply and divide with 1 plus 2i. So 1 plus 2i divided by a square plus b square. 1 1s are 1, 2 2s are 4. So 1 plus 2i divided by 5. This is the value of 1 by z1. Now next one, calculate 2 by z2. 2 by z2. That is 2 by, what about z2? 1 plus i. Now multiply and divide with 1 minus i. So 1 minus i by 1 minus i. So numerator 2 1s are 2, minus 2 into I 2i, denominator a square plus b square 1 plus 1. So we can write 2 minus 2i by 2 or simply 1 minus I. Next, z3 by, now addition of these two, 1 by z1 plus 2 by z2 equals to 1 by z1 is 1 plus 2i by 5 plus 2 by z2 is 1 minus I. So 1 plus 2i plus 5 ones are 5 minus 5 into I, 5i divided by 5 is 6 minus 5i divided by 5. 6 minus 2 minus 5 is minus 3. So this is 1 plus z1 by 2 by z2. Next we have to calculate z3 by z2. So what about z3? That is 3 plus 4i by 1 plus I. So multiply, divide with 1 minus I by 1 minus I. So denominator a square plus b square is 1 plus 1 is 2. 3 1s are 3, minus of minus plus 4. 3 into I is minus 3i. 4 into I is plus 4i. So 3 plus 4 is 7 plus I by 2. Now we have value of this one is mod, first bracket is 6 minus 3i by 5. Now second bracket is 7 plus I by 2. So we have to find mod. So using the property of mod z1 into mod z2 equals to mod z1 into mod z2. Finding modulus of separate. So 6 6 are 36 plus 3 3s are 9 divided by 5 5s are 25. 36 plus 9 is 45 by 5 into 7 7s are 49 plus 1 1s are 1 divided by 2 2s are 4. So this will become root 45 divided by 5, and this is root 50, means we can write 25 2s are, so 5 root 2 divided by 2. So 5 get cancelled, and root 2 by 2 we can write root 2. So answer is root 45. Root 2 divided by 2 is root 2. So answer is root 45 by 2. Okay, so first find out 1 by z1 plus 2 by z2, addition of these two, z3 by z2. Okay, now we have to use the property mod z1 into z2 is mod z1 into mod z2, finding modulus of first bracket and second bracket separately. Okay, so okay, same terms get cancelled, you will get under root 45 by 2 as our third option. Now locus problem is the locus of z x plus iy such that imaginary part of z minus 3i by iz plus 4 equals to 0. So first find out the value of z minus 3i by iz plus 4. So z here x plus iy minus 3i by I times of z value is x plus iy plus 4. X plus iy plus 4. So this one we can write further. If you take x common, so x plus I times of y minus 3. So here I into I is I square. So x into I is xi, I into I is I square. So this will we can write 4 minus y plus xi. I into I square is minus 1 minus y, so 4 minus y plus xi. Now rationalizing the denominator, so multiply and divide with rational factor of denominator, that is 4 minus y plus is there, multiply with minus xi divided by 4 minus y minus xi. So given that imaginary part of z is 0, okay, so if you consider imaginary part of z means complete denominator always becomes 0, just equate the imaginary part, okay, not real part, only imaginary part. So imaginary is 0. So x into minus xi, that is minus x square. I am taking coefficient of I terms only. So x into minus xi is minus x square I. So just I am taking coefficient of I, that is minus x square. Now these two. So plus y minus 3 into 4 minus y equals to 0. So minus x square plus y into 4y is 4y, y into 4y is 4y, y into minus y is minus y square, minus 3 4s are minus 12, minus of minus plus 3 into y 3y equals to 0. So minus x square minus y square plus 7y minus 12 equals to 0. If you write in order, therefore required equation of locus is x square y square minus 7y plus 12 equals to 0. Any option is there? So first two terms represent x square plus y square is a circle. So option 3 and 4 may be, but x square minus y square, x square minus y square, these are not the right answers. So 50-50. Now third term is minus 7y plus 12, minus 7y plus 12. So third option is the correct option. Fourth option plus 7y minus 12 is there. This is wrong. Therefore, locus of z, if z equals to x plus iy, if imaginary term of this one is 0, is x square plus y square minus 7y plus 12 equals to 0. So, like this one question will come in your Eamcet exam related to locus. Okay.